Okay, I'm gonna using the question 1 as an example to explain how to solve a word problem. And usually there's 4 steps involved in solving a word problem. The first step is, let's see, the first step definitely is read the question, right? Right, question. And in this process, you need to read the entire question. And, and one thing important in this step is to understand the goal. What's the goal of this question? What do you want to solve, right? Understand the goal. And the second thing is, while reading the question, you start picking up some keywords and using those words to define notations. And those notations should be helpful and for you to organize your question, organize your thoughts. For example, if how many books Tom has, then probably you can use T as the variable, right? How many books Jack has, you probably use J as a variable name. So the third step is translate sentence into equations. I usually call it S2 equation, right? And then in this step, you translate, while you translate sentences into equations, you need to keep thinking of, keep asking yourself, how many equations I have, how many unknowns I have. If you have 2 unknowns, you only set up 1 equation, that means you probably needed to set up another equation in order to solve the 2 unknowns, right? And the 4th step actually is very mechanical, is solve the equation system. So I'm going to use this example to show you. Go through those 4 steps. Okay. Let's go read the question. The question is this: a special cereal mixture contains rice, wheat, and corn in the ratio of 2 to 3 to 5. If a bag of the mixture contains 3 pounds of rice, how much corn does it contain? I think the first thing you usually pay attention to is to understand what they want you to solve, right? You want to solve the corn. How much corn there, right? That's the question. And it's very natural if you read the question. It's quite natural to use the first letter of some keyword to define the notation. For example, it's talking about rice, wheat, and corn, and it's talking about the weight, right? It's because the unit is pound. So it's very natural for me to think of using R as what? As a weight of rice, right? In the bag, right? In a bag. In the bag mentioned, it's a bag. So the weight of rice in the bag is R, right? You can use that. You can say, oh, I really think it's a weight of rice. Then you use W subscript R. It's totally fine. It really depends on what you want, right? I would like the simple way, just use R in this example. You can definitely use WR, okay? So similarly, you can define what? Define wheat, use W, right? So you have W, you also have C, right? It's just a weight of wheat, right? And weight of corn, right? So it's really helpful for you to use something you can remember well. Use the first letter, right? R, W, and C, right? Corresponds to R, W, and C. Okay, good. The other thing, when you are first exposed to a word problem, you always have the concern that why I keep throwing those notations. It's just make the problem very hard. Actually, you should get used to use more and more notations. It's totally fine because more notations, more equations, you can finally solve it. So you don't need to worry about using more notations. Okay. So in this question, I'm gonna because this is a ratio problem, I'm gonna solve this in in a typical way we solve it, okay? A typical way of solving a ratio problem is introducing a factor. Let me just quickly go over the idea, right? Say, we know the ratio between ratio of rice to wheat is 2 to 3, right? So it means R to W is 2 to what? 3, right? Based on this, right? 2 to 3 and rice and wheat, right? But the question, but we need to notice, whenever you see those, you need to immediately understand R, the true amount of, the R is what? R actually is equal to 2 is coming from here, times a factor. The factor is canceled out to when you form a ratio, but before it cancels out, the true amount of R actually is 2 times F. Similarly, W equal 3 and F. The reason we have R over W equal 2 over 3 is because once you put them into ratio, then you have this, right? 2F, 3F. And then cancel out, they get 2 to 3, right? So you need to understand this. If you go back to the, if we use the approach with the factor, then we just write the factor out, okay? Then we write the factor out like this. Okay, hold on. So we have this, right? We write the factor out, and factor is another additional variable, right? So don't worry, you're gonna solve it. So you from now on you need to get more get used to having more and more notations. It's totally fine. Okay, I'm gonna extend this. So I have R equal to 2F, W equal to 3F, and what? And con equal how many F? 5, right? Correspondence. So this is 5F. Okay. So I have how many? So while writing down those notations and equations, you need to count how many equations and how many unknowns you have. Here you have 4 variables unknowns, right? Variables, they are R, W, C, and F. But how many equations do you have? You only have 1, 2, 3. So you have 3 equations. So okay, so this means in order to solve C, you probably need another equation, which is, you just keep looking more sentences. So here, look at this sentence. So basically, these first 3 equations, those 3 equations, right? Those 3 equations coming from the first sentence. It's just coming from, actually, I'm just highlighting this first sentence, right? This first sentence is corresponding to the first 3 equations, okay? So we need additional equations. So we are looking for another sentence. Obviously, is the sentence, which is if a bag of mixture, if the bag of the mixture is 3 pounds of rice, contains 3 pounds of rice, this is a sentence. This sentence has an equation. The equation is very simple, right? The equation is just R equal to 3 pounds, right? You don't write the units, but it's fine because we are not doing physics right now. We're thinking just mathematical equation. Okay, so you have 4 unknowns, 4 variables, right? But we have how many equations? We have 4 equations. So basically, we have 4 variables and 4 equations. Right? So bingo, they are equal, right? So bingo, awesome, right? You put a smile if you want. That means you can solve this problem, right? So you're very happy. You should. Once you find the number of equations equal to the number of unknowns, okay? Now, so we already set up a equation system. I'm not going to solve it for this time because we have a more complex problem now. I will leave you to solve it. Okay, thank you.